Hello students, I hope you know how to find the area of the region using single integration. Now in this video we shall discuss how do we find the area of the particular region using double integration. Area using double integration, what you know about the area using single integration, let us recall it first and then we will convert it into the double integration. Suppose we have given the function y is equal to f of x, which is bounded by x is equal to a to x is equal to b. Then I want to find out the area of this particular region. For this region R, I want to find the area. Then you know how you are finding the area for this region using single integration. Area of the region R is equal to integration x is equal to a to x is equal to b f of x dx. Now here my f of x is y, so I can rewrite this equation as equal to integration x equal to a to b y dx. Now see what I am doing. This is integration x equal to a to b yx dx, right? My function is y. I am using the concept of antiderivative. So how I am writing y in terms of its derivative? So I can rewrite it as this is equal to integration x is equal to a to b integration dy dx. Right. Now observe here the integration dy. I have to write the limit over y. So if you observe the region R, then I have to write the limit for this region R. Right. I have to write the limit for this region R for y. I have to write the limit of this region for y. How do we write the limit for y? We draw the vertical line. So when do we draw the vertical line? Right. We are entering into our region from this line and the equation of this line is y is equal to 0. Right. Now we continue moving inside the region and we exit from this curve. Right, and the equation of this curve is y is equal to f of x. So y equal to 0 to y is equal to f of x. Right, so y equal to 0 will be my lower limit, y equal to f of x will be my upper limit. That I mentioned here, y is equal to 0 to y is equal to f of x. And therefore, area of the region R can be represented by integration limit over x a to b integration limit over y 0 to the given function f of x then dy dx. So if you observe this formula, then whatever we have given in terms of single integration, the same quantity will be converted into the double integration x equal to a to b integration y equal to 0 to f of x dy dx. So what is the function here? See, you already worked with the number of examples in double integration, right? So here the function is 1 into dy dx. So f of xy is 1 here, and therefore the formula for area of the integration in terms of double integral is area of the region R is equal to integration x is 1 a to b integration y is equal to 0 to f of x 1 into dy dx. But again concentrate over here the limits. These are the limits for this region R. So in general you can say that suppose I have given any region R, then area of the region R is nothing but double integration over r dy dx. So this is the simple formula for the area of the region R. What you need to work with, you only need to write down the limit. Now as I explained, here the function is 1, which is continuous function. So by Fovini's theorem, in place of dy dx you can write dx dy also. So which is same as double integration over r dx dy. So for any region R, you need to write down the limit of y, the limit of x in case of dy dx. In case of dx dy, you need to write down the limit for x, for limit for y. Let's discuss this concept with some particular examples. Here the exercise is find the area of the region bounded by the curves x equal to 0, y equal to 2x and y is equal to 4. So what is our first task always? We draw the curves, we find out the region and then we write the limit. Here we have two cases. You can write the limit for dy dx or dx dy. So first task, let us draw the curve and find out the region. So here we have the curves. The curve x equal to 0 is this line, x equal to 0. Let me mention it. X equal to 0. Next, the line y equal to 2x is this line, y is equal to 2x, and this horizontal line is y equal to 4. I have to mention all the intersection points. So this point is x value is 0, y value is 4. This intersection point is when y is equal to 4, x is equal to 2, and this intersection point is origin 0, 0. Now, what is my region? The region is bounded by these three curves. Y equal to 4, x is equal to 0, and y is equal to 2x. So this portion is my region R. Right. Now I have to find out area of this region. Okay. Now see, did you observe our region? This is the right triangle. This is 90-degree angle. Right. So whenever we have given right triangle, you know the formula for the area. The formula for the area of the right triangle is 1 upon 2 into the length of the product of the length of. Whenever we have given right triangle, then the formula for the area is 1 upon 2 into the product of length of these two line segments. Right, these two sides which make the right angle. So, can you tell me what is the area? Direct area of the region R is equal to 1 upon 2 into what is the length of this line segment? This is equal to x equal to 0 to x equal to 2. So the length is 2 and the length of this segment is y equal to 0 to y equal to 4. So which is 4, and therefore the area of the region R is 4 units square. Right. Because this is right triangle, so easily we can talk about. But using double integration, how do we find the area? So let us try with the double integration. Area of the region R is equal to double integration dy dx. Y is equal to and x is equal to. Whenever we are writing dy dx, first I need to write down the limit of y. How do we write limit of y? We draw the vertical lines from down to upward direction. So let us draw the lines from down to upward direction. So the lines are intersecting our region to this curve. The curve is y is equal to 2x. That means we are entering into the region from this line. We are moving inside our region, right? And then we exit from the region. When do we exit from the region? The equation of this curve is y equal to 4. So y equal to 2x to y is equal to 4. As you know, entry becomes the lower limit, exit becomes the upper limit. So y is equal to 2x to y is equal to 4. Now I have to write the limits for x. Outer limit must be constant. So observe the x-axis. How much portion of the x-axis covered by the region? So I need to take the projection. When you take the projection, right, the projection of this point, the projection of this point lies here, x equal to 2, right? So the portion of, so this is the portion of the x-axis, x equal to 0 to x equal to 2, covered by the region, right? X equal to 0, the left hand side point becomes the lower limit. X equal to 2, the most right hand side point becomes the upper limit. So x is equal to 0 to x is equal to 2, right? Then what we have to do? We have to integrate the function. What is the function here? Function is 1 with respect to y. So what is the integration of 1 with respect to y? Is y. So this is x is equal to 0 to 2. Integration is y from y equal to 2x to y equal to 4 dx. And therefore this is equal to integration x equal to 0 to 2. When do we substitute the upper limit? This is 4 minus 2x dx. Now what is the integration with respect to x? So the integration is 4 times x minus integration of 2x. So what is the integration of x? Is x square divided by 2. So the quantity is 2x square divided by 2. 2 and 2 will be cancelled out. So it becomes only x square. So 4x minus x square from x equal to 0 to 2. Now see, when do you substitute x equal to 2, what happen? This is 4 into 2 is 8 minus 4 square. So 4 into 2 is 8 minus 2 square is 4. So 8 minus 4 is 4. And therefore the final answer is equal to 4. The end of exercise. Now if you are thinking that suppose in place of dy dx you want to write dx dy, then what? So let us try with dx dy. Area of the region R is equal to double integration dx dy. For dx dy, what you need to do? You have to draw horizontal lines from left to right. So once you draw the horizontal lines, the lines are intersecting the curve x equal to 0, right, which is the part of our region. So we are entering into the region from x equal to 0. We continue our journey and we exit from the region by the line y equal to 2x. So x equal to 0 is my entry and y equal to 2x is my exit, right? X equal to 0 the lower limit, y equal to 2x. So what is x? X is equal to y divided by 2 and therefore x is equal to 0 to y divided by 2. Now outer limit of y must be constant. How do we write? How much portion of the y axis is covered? So this is the portion. Here y equal to 0, here y is equal to 4, and so y equal to 0 to y is equal to 4. You need to integrate this quantity. You need to integrate this quantity with respect to x first, then with respect to y. I left this to you. Let us move for the next exercise. The exercise is find the area of the region bounded by the curves y equal to x minus 2, y equal to minus x, and y is equal to under root x. What is the first task? Identify the curves, draw the curves, find out the region. So the first curve, y equal to x minus 2, is the line. Which line it is? The line when x is equal to 0, y is equal to minus 2. When I substitute y equal to 0, what is this? X minus 2 equal to 0, so x is equal to 2. So when y is equal to 0, x is equal to 2. So y equal to x minus 2 is the line passing from these 2 points, 0 minus 2, 2 and 0. You know the line y is equal to minus x, the line passing from the origin when x is 0, y is 0, when x is 1, y is minus 1, right? And the third curve, y is equal to under root x, take square both sides. So this is y square is equal to x. This is the parabola. So here is the region. This is the line, yellow colored line, y is equal to minus x. Let me mention its equation. The line y is equal to minus x. The green line, y is equal to x minus 2, y equal to x minus 2, and this is the parabola, y square is equal to x. Let us note down all the intersection points. This intersection point when x is equal to 4, y is equal to 2, then this intersection point when x is equal to 1, y is equal to minus 1. This intersection point when x is equal to 0, y is equal to 0, the origin. Now in this figure, what is our region? The region is y equal to x minus 2, this curve, and the line y equal to minus x. So our region R is bounded by 2 lines and 1 curve, which gives me this portion. So this is our region R, right? I hope the region R is clear to everyone. Now let us find out the area of this region. How do we find the area? Using double integration. So area of the region R. So area of the region R is equal to double integration. What you want to write? dy dx or dx dy? Whatever. Suppose I am writing dy dx over R. So first I have to write the limit of y, then I have to write the limit of x, right? Now see, when you observe the region, right, then the region has this corner point, right? Whenever the region has the corner point, now you observe, when you move vertically from down to upward direction, then what is happening here? If you are entering from this side, right, that means you are entering from the line y is equal to minus x. Suppose you are entering from this side, that means you are entering from the line y is equal to x minus 2. So here we have two entry, either the line y equal to minus x or the line y equal to x minus 2, and they are dividing from these corner points, right? So whenever your region has, this is only the observation. If your region has the corner point, then from the corner point divide your region into two parts, the left side of the corner points, the right hand side of the corner points. So let us divide the region into two parts. So this part is region R1 and this side part is region R2. So my R is union of these two, R1 and R2. So I am writing this is equal to R1 union R2, and which is equal to double integration over R1 dy dx plus double integration over R2 dy dx. And so therefore this is equal to double integration dy dx. Now let us write the limit for the region R1. Right, for R1 what is happening? You are entering, so I am writing here for R1. You are entering from this curve, y is equal to minus x. So y is equal to minus x is my entry. You are moving to the upward direction. So we are moving to the upward direction and we exit from this curve. What is the equation of this curve? Y square is equal to x. So y square equal to x. I have to write limits for y. So y equal to minus x, my entry becomes the lower limit. I write here y is equal to minus x and y square equal to x. So what is y? Actually y is equal to plus or minus under root x. So either y is equal to root x or minus root x. But we are in the first quadrant where x and y are positive. So we choose y equal to under root x. Y is equal to under root x. Clear? So this is the limit for y of the region R1. Now x must be constant. So how much portion of the x-axis covered by the region R1? This is the portion, this much portion, only this much, right? So from x equal to 0 to here x is equal to 1. X equal to 0 to x is equal to 1 plus double integration. Now let us write for the region R2. Observe R2. We are moving towards the region. We are entering from this line. Equation of this line is y equal to x minus 2. So I am writing here for R2 y is equal to x minus 2 to, once we are going to this direction, we exit from the region from this curve, y square equal to x. So our exit is this, y square is equal to x. As you know, we are still in the first quadrant. So y is equal to x minus 2 becomes my lower limit and y square equal to x. Just like this, y square equal to x. So which equation I need to choose? Y equal to root x or minus root x? Once we are in the first quadrant, we choose root x. That will be my upper limit, y equal to root x. Now what about x? How much portion of the y-axis, how much portion of the x-axis is covered by the region? So from this point to, are you thinking about this point? No, this is not the point. See, when you take the projection of this region on the x-axis, the projection will be till this point. When you take the projection of this region on the x-axis, the end point of the region is this, and its projection lies to this point. So this much portion from x is equal to 1 to x is equal to, this is 4, right? See, the point is 4 2. So x is equal to 1 to x is equal to 4. So I write x is equal to, so I write x is equal to 1 to x is equal to 4 dy dx. Now let us evaluate this integral. Therefore, area of the region R is equal to integration x equal to 0 to 1. What is the integration of 1 with respect to y is y? We have substituted the limits, right? So can I write direct this is square root x minus lower limit is minus x dx plus integration x is equal to 1 to 4. Again the integration is y. I am substituting the limit, so this is root x minus x minus 2 dx, right? So this is equal to integration x is equal to 0 to 1. Now I need to integrate this square root x. Now I need to integrate this square root x. So what is the integration of this square root x? See, look at here. See, look at here. Square root x, which is equal to x raised to 1 by 2. I am integrating with respect to x. So integration with respect to x equal to x raised to 1 upon 2 plus 1 divided by 1 upon 2 plus 1. Now what is 1 upon 2 plus 1? Is 3 by 2. So this is x raised to 3 by 2. Divided by 3 by 2 is nothing but 2 by 3. Right. So the integration of square root x is 2 upon 3x raised to 3 by 2. Let us mention here. So this is equal to 2 by 3 x raised to 3 by 2 minus minus plus. Now what is the integration of x? X square divided by 2 from x is equal to 0 to 1 plus the same thing, integration of root x, which is equal to 2 by 3 x raised to 3 by 2 minus x square divided by 2, which is the integration of x, minus minus plus 2 has integration 2x from x is equal to 1 to 4. And so this is equal to, when you substitute x is equal to 1, when you substitute x is equal to 1, this is 2 divided by 3 plus 1 divided by 2. X equal to 0 is the lower limit, but when x is equal to 0 everything is 0, so I am not going to mention it, plus now when x is equal to 4, so this is 2 by 3, 4 raised to 3 by 2 minus 4 square is 8 minus 4 square is 16 divided by 2 plus 4 into 2 is 8. Minus sign for the lower limit. Clear? X equal to 1, so this is 2 by 3 minus 1 by 2 plus 2. Evaluate this quantity. This is equal to 2 by 3 plus 1 by 2 plus. What is 4 raised to 3 divided by 2? Look at here. 4 raised to 3 divided by 2 is equal to, first I find square root of 4. What is square root of 4? Is 2. So this is 2 cube and 2 cube is 8. So this is 8 into 2 is 16 divided by 3 minus 16 divided by 2, which is 8. So I can cancel out 16 divided by 2 and 8. And so this is minus 2 by 3 plus 1 by 2 and minus 2. Then we can cancel out 2 by 3 minus 2 by 3. 1 by 2 and 1 by 2 is 1. 1 minus 2 is minus 1. Right. So the total quantity is 16 upon 3 minus 1 by 2 plus 1 by 2, which is 1 minus 2 is minus 1. So 16 by 3 minus 1. So this is equal to 16 by 3 minus 1. And which is equal to 13 divided by 3. I repeat again, we have chosen double integration dy dx, so we have written the limit of y, and we observe that there is one corner point. So first I divide my region into two parts. I write for r1, I write for r2. Now you are thinking that if I am writing dy dx and we need to divide the region into two parts, so suppose I write dx dy, then what? So area of the region R, double integration over R dx dy. Then you have to write first limit of x. Then you have to write first limit of x. For limit of x, you need to draw the horizontal line. So whenever you are drawing the horizontal line, you are entering this region from this side, right? Or you may enter into this region from this, because this point is the corner point. This point is the corner point here, right? So you are entering either from the curve y square equal to x, or you are entering from the line y is equal to minus x. So in this case also, you need to divide the region into two parts, where we are entering from this and exit from the green line. We are entering from yellow line and exit from the green line. So exit is unique whether we have two different entries, the curve y square equal to x or the curve this one, right? So can you write down the limits? Find the area of the region defined by the x range is 0 to 2 and the y range is 2 minus x, 2 under root 4 minus x square. What is the first task? Identify the curves, draw the curves and find the region. So let us identify the curves. We have these curves, x equal to 0, 2x is equal to 2. So x equal to 0 is the line, x is equal to 2 is also line. This is y-axis and this is the line parallel to y-axis from 2 unit. Then this is what? Y is equal to 2 minus x. Y equal to 2 minus x. When x is equal to 0, y is equal to 2. When y is equal to 0, x is equal to 2. Right. So this is the line passing from these 2 points 0, 2 and 2, 0. Next, which equation is this? Y is equal to under root 4 minus x square. Take square both side. So y square is equal to 4 minus x square, and therefore x square plus y square equal to 4. This is the circle with center 0, 0 and radius 2. X square plus y square equal to r square. R equal to 2. Right. So the circle 0, 0 and radius 2. So what we have to do? We have to draw the line x equal to 0, x equal to 2, the line y equal to 2 minus x, and the circle with center 0, 0 and radius 2. These are the curves. X equal to 0, x equal to 2, y is equal to 2 minus x, And these are the curves: x equal to 0, x equal to 2, y equal to x 2 minus x, and x square plus y square equal to 4. Now the question is, what is our region? What we have given? 0 to 2, x, right? X from 0 to 2. So x is from 0 to 2 fixes this infinite strip. That simply mean my region lies into this vertical strip, right? Now in this strip, y is equal to 2 minus x, which is line to this circle, right? This is the range of y. So y vertical, we have to move from line to circle. So from line to circle is this. See, if you are starting from this, then this is circle to line, which is not the situation. The situation is the left side is line, that is the bottom side is the line, and upper side the circle. So when you are moving, now this is the line, y equal to 2 minus x to this circle, right? So my region is this portion. So my region is this portion. So my region is this portion. This is the region R. Now let us find out the area for this region. Area of the region R is equal to double integral over R dy dx. Now observe one thing here. In my region, this is a circle, x square plus y square equal to r square. So what happen if I convert the Cartesian coordinates into polar coordinates? Would it become easy? So let us try with polar coordinates. When do we convert dy dx into the polar coordinates, x equal to r cos theta, y equal to r sin theta, then dy dx becomes r dr d theta. So this is equal to double integral r dr d theta. What I have to do? First I have to write what is my r, my radius. And as you know, to write down the limit on radius, we are starting from the origin, r equal to 0 to this one. We are increasing r. But this is not the part of our region. My region start from this green line, right? So my r will start from this green line. So do you know what is the equation of this green line in terms of r? What is y? Y is r sin theta is equal to 2 minus r cos theta. Therefore, r sin theta plus cos theta, r sin theta plus r cos theta. So I am taking r common. So sin theta plus cos theta is equal to 2. And therefore, what is r? 2 upon sin theta plus cos theta. That means my radius start from this, and again I am increasing my radius, and this is the end of our radius. And what is the equation of this circle? X square plus y square, which is r square, is equal to 2 square, 4. And therefore r is equal to 2. So my radius start from this and end at 2, right? R is equal to 2 upon sin theta plus cos theta to r is equal to 2. What is my theta here? See, so my region touches to the positive x-axis as well as positive y-axis. So this line has equation theta equal to 0. So I have to collect from theta equal to 0 to all these lines theta equal to pi by 2. And so theta is equal to 0 to theta equal to pi by 2. So this is equal to integration theta equal to 0 to pi by 2. Now let us integrate r with respect to r. What is the integration? R square divided by 2. So 1 upon 2 I am writing outside, and this is r square with the limit. Upper limit is r equal to 2, lower limit is r is equal to 2 upon sine theta plus cos theta. D theta. So this is equal to 1 upon 2 integration theta equal to 0 to pi by 2 r square. So 2 square is 4 minus 4 upon sine theta plus cos theta whole square d theta. So if you take 4 common, then this is 2, theta equal to 0 to pi by 2, 1 minus 1 upon, what is this? Sine theta plus cos theta whole square. Look at here, a plus b whole square, s square plus 2ab plus b square. So sine theta plus cos theta whole square is equal to sine square theta plus 2 sine theta cos theta plus cos square theta. So sine square theta plus cos square theta, which is 1, plus 2 times sine theta cos theta. Right. So this is 1 plus 2 times sine theta cos theta d theta. And so this is equal to, now see, when you take this is LCM, then 1 plus 2 sine theta into cos theta into 1 minus 1, so which becomes 2 times integration theta equal to 0 to pi by 2, 1 plus 2 times sine theta cos theta minus 1, which is 2 sine theta cos theta divided by 1 plus 2 sine theta cos theta d theta. Now see, how do you integrate this quantity 2 times sine theta cos theta upon 1 plus 2 times sine theta cos theta? So I am using one trick here and adding 1 and subtract 1 in the numerator. So this is equal to 2 times integration theta equal to 0 to pi by 2, 1 plus 2 sine theta cos theta minus 1 upon 1 plus 2 sine theta cos theta d theta. Right. So this is the pair 1 plus 2 sine theta cos theta. Divide by this, which is 1. So this is 2 times theta is 0 to pi by 2. This bracket divide by the same denominator. So which is 1 minus 1 upon 1 plus 2 times sine theta cos theta d theta. Now you can easily integrate this one, but what about this integration? So let us discuss this also. This is equal to 2 times integration theta equal to 0 to pi by 2, 1 into d theta is d theta minus integration 2 times theta equal to 0 to pi by 2. What about this one? See, this is 1 upon 1 plus 2 times sine theta into cos theta is sine theta plus cos theta whole square. This we have already seen. Sine theta plus cos theta whole square is represented by 1 plus 2 times sine theta cos theta. So here we are applying only the reverse thing. Now look at here. 1 upon sine theta plus cos theta whole square. I am taking sine theta common. So this is equal to, I am taking cos theta common. So this is equal to 1 upon 1 plus sine theta upon cos theta, which is tan theta whole square. When do you take cos theta common, then here we have cos theta. So this is equal to 1 upon cos theta is sec theta. Right, actually this is cos square theta. So sec square theta divided by 1 plus tan theta whole square. Right, now suppose I assume that this tan theta is my x, then this is what? 1 plus x whole square. And what is sec square theta? Is the derivative of tan theta. So here we have x dash. Right. So what is the derivative of 1 plus x? Is x dash. That means you can compare this with I have given the function f whole square and here it's derivative f dash. Right. So this is nothing but f raised to minus 2 into f dash. Now what is the integration of this kind of functions? The integration is nothing but f raised to minus 2 plus 1 divided by minus 2 plus 1, which is equal to f raised to minus 1 upon minus 1. This is nothing but minus 1 upon f. Right. This is minus 1 upon f. What is my f? F is 1 plus x. Right, so this is nothing but, the integration is nothing but minus 1 upon 1 plus x. What is x? X is tan theta, that is nothing but minus 1 upon 1 plus tan theta, that is the integration of this quantity. So this is equal to 2 times the integration is theta from theta equal to 0 to pi by 2 minus 2 times the integration is 1 upon 1 plus tan theta with minus sign, so minus minus plus, where theta equal to 0 to theta equal to pi by 2. And so this is equal to 2 times, I am taking common, when theta equal to pi by 2, this is pi by 2 plus, when theta equal to pi by 2, what is tan theta? Tan pi by 2. You know that tan pi by 2 is infinity. Right. So look at here, 1 upon 1 plus tan pi by 2 is infinity. So this is 1 upon infinity, which is 0. Right. So this is 0, minus sign for lower limit. When theta equal to 0, tan 0 is 0. So this is only 1. And therefore the final answer is 2 pi by 2 is pi minus 2. This is the area of this region. This is very nice region. You may verify your answer. What is the area? Here pi by 2. Now look at the region R. The region R is this. If you consider only the circle, then what is the area of this circle? This is the circle of radius 2. So what is the area? Is pi into r square. R is equal to 2. R is equal to 2. So what is the area? 4 into pi, because the radius is 2. So 4 pi is the area of whole circle. Here I have to consider only 1/4 circle, right? So that area is divided by 4, and which is equal to pi. But this pi is the area of this fourth part of the circle. Now I need to subtract this area, and this is nothing but the right triangle. So what is the area of this right triangle? That is 1 upon 2 into the product of this length into this length. This is 2 and this is also 2. So this 2 into 2, which is equal to 2. Right. So area of my this region is what? The total area minus this, which is pi minus 2. So sometimes you can use this kind of trick, but if you want to find out the area using double integration, then this is the only method.